Block A and C start from rest and move to the right with acceleration of A equal to as 12t meter per second square and acceleration of C equal to as 3 meter per second square. Here t is in seconds. The time when block B comes to rest after t equals to 0 is in the pulley block constrained systems. The net power delivered by tension force is always 0. That is, we can write this as sigma t bar dot v bar equals to 0. This can also be written as sigma magnitude of tension multiplied by magnitude of velocity multiplied by cos of angle between tension and velocity is equal to 0. Now let us solve this problem by using this statement. Let us suppose the velocity of A is VA and velocity of C as VC and velocity of B as V. It is given that A block and C block are moving towards to right. Now let us suppose that block B is moving vertically upwards. Now applying this statement, we can write the tension in this string is capital T. So since the string connecting from A to C is a single string, so tension at every point on it will be T. Since the pulleys are massless, the tension in the string which is connected between this movable pulley and block B should be equal to as 2T. Therefore, we can write T multiplied by VA plus 2T multiplied by V plus T multiplied by VC into minus 1 is equal to 0. Then this equation implies that velocity of A plus 2V minus Vc equals to 0, which implies 2V is equal to Vc minus Va. On differentiating this equation, we get 2 times dV upon dt is equal to acceleration of C minus acceleration of A. Acceleration of C is given as 3 and acceleration of A is given as 12t. So we can write 2 times of dV upon dt equal to as 3 minus 12t. So this implies dV is equal to 3 minus 12t times of dt upon 2. Now in the question it is asked to find when the block B comes to rest after t equals to 0. That means initially the block B is at rest and now he is asking to find after what time again the block B comes to rest. So integrating this, we can write integral dV is equal to 3 minus 12t upon 2 dt integral. So when the time is 0, its initial velocity is 0. When the time is t, let us suppose the block B has come to rest. So this implies 0 is equal to 1 upon 2 times of 3t minus 6t square. So this implies 6t square is equal to 3t, which implies t is equal to half second. Therefore, the block B will again come to rest after a time of t equals to half second. Therefore, the correct option is 4.